Hey there, guys and gals. Welcome to Unit 1, Lesson 4 of Geometry. In this one, we're going to be talking about angle measures. We're going to get some new vocabulary, as is going to be the norm for geometry class. And we're going to do one example. We're mostly just getting a bunch of new vocabulary. And I think we're going to learn kind of another postulate. We won't really call it that at this point, but we learned segment addition. We're not gonna call it a postulate, but we're gonna end up using another one, kind of like segment addition. We're gonna learn angle, something with angle addition. So let's jump in. So the first thing that we want to define, we talked about points, lines, planes, and we talked about line segments, right? In a couple lessons ago. In this video, we're gonna talk about another new shape type that we can form out of lines. And so we learned about line segments. So line segments, of course, they end on both sides. Well, so this is a line segment, right? Line segment. So this could be segment. How about XY? Why not? Sound good? Yes. So that would be labeled, remember, this way, right? Where we just have a line above it without arrows. So we put arrows on it, then that's going to be, that's going to be a full line, right? We can also have our new concept, our new type of line section is called a ray. Okay, a ray looks like this. How about we draw ray AB? That sounds fine. It looks like this. It also takes 2 points to define a ray, just like it does a line and a line segment. Same idea. And so you can tell what it does. So it stops on one end and then it goes to infinity on the other end. So it's kind of like a line segment and a line stuck together, and this is what comes out, right? And so that's what a ray is. Now, it's worth noting that unlike a line, so line XY and line YX are the same line. They have no difference. They're defined differently, but especially line segments, we may see with things like reflexive property. It depends on how the shapes are twisted and whatever else. We'll see that lots later. But for a ray, in this case, if we had, let me make this into, I tried. That's close enough. Good enough. So if we turn this into line AB, it is very much worth noting that ray AB, now you might guess how we symbolize that. We symbolize it with a ray drawn on top, right? Ray AB is not the same, not equal to, not congruent to ray BA, because the direction here does actually matter. Those rays are not equivalent. They are not even opposite rays. We're going to talk about what an opposite ray would be with an example here in a minute. So that's what a ray is. Now, the title of this lesson was angle measures. So you might guess that angles are made up of rays, and that's exactly true. So an angle, of course, is something like this, where we have this guy and that guy, and then we've got these guys. So you notice now we're going to get our first naming scheme for an angle. So let's do this J, K, L. So and you can get this out in words, and if you want to copy down what I'm saying, you're welcome to do so. I'm not going to write this out. But what an angle is, commonsensically, it is a couple of rays with a common endpoint. So 2 rays that intersect at a common endpoint. So now we've got an angle here, right? Now, this angle right here could be named one of 2 ways. So the way we label angles is we draw a little angle symbol like this. And so this one is, we could call this either angle J, K, L, or we could also call this angle LKJ. It would not be correct to say that this is angle KLJ. That would be an angle that would live like up in here. And you notice that what the important and the difference is, and what I said different between that one and these other two, is the fact that the vertex, and let's go ahead and label that for vocabulary's sake, the corner of an angle is called the vertex of the angle. The point that happens at the vertex has got to be the midpoint. And this is important, right? Because if we were to have this triangle shape, then, and I would start to list points in here, if I was to list angle JLK, that's a different angle. That's this one up here. If I was to list this one up here, LJK, that's this one up here. And so it's really important that we talk about them and talk about them differently. So the vertex has to be the one in the middle when we're labeling angles, and that's really important. Sometimes, and we'll see this especially when we start talking about triangles or when we're talking about parallel lines or any of these things, sometimes you will also see angles labeled as... I'm undoing something that I don't want to undo. That's fine. We'll leave this little hat. You'll see this. You'll see this when we start talking about like congruent angles and stuff. That's a mark that we use for that. Kind of like we used. I think we've talked about tick marks for segments already. And so we use this kind of symbol for like congruent angles. So essentially all this says is this angle is congruent to itself. Yay, which is a property. We'll talk about that later. But what I was saying before I got distracted by my little pink angle measure is that sometimes you will see angles labeled as numbers. Now, this can be confusing because this could be one unit, right, as well. And the way we distinguish that is very often if this is actually the angle measure, which we're not going to talk about in this lesson, we'll talk about a lot later, is we'll see a degree mark on there, right? We won't talk about radians for a long time. So you'll see that labeled. You might say angle 1, and then we might have another one off over here that's angle 2. That's sometimes for ease and whatever else. But you can always use this format to name those angles. Let's see, where are we talking about next? So let me see if I can get a color here. Let me see about reducing my... No, I don't want to do that. But I can grab a different brush. Yeah, that'll work. That will totally work. So there is for every angle, every single one of them, there is an interior and an exterior. And it works out kind of like you'd expect. I'm going to actually draw, I was going to do this on this angle, but I'm actually going to do two examples. We haven't talked about what these terms are, though, but you probably know them. We're going to draw, let me draw an acute angle and an obtuse angle. So, oops. So here is going to be an acute angle example. I'm not even going to label the numbers. Let's just do a white one and then this light purple one. And then we'll do an obtuse example. So you can kind of see the difference of how interior and exterior work. So for both of these angles, both of these angles are kind of opening up, right? For both of these angles, let's grab our opacity brush again and give us a little bit bigger. All of this on the outside of the angle, everything out here is the exterior. And I'll label that in words here in just a second. Same for this on the outside of the angle. And again, it's kind of common sense. It's kind of obvious, right? All right, the outside out here is the exterior, right? All of this stuff. Now then, let's just use a different color. How about this yellow? All of the inside of the angle, all of this part right here is the interior of the angle. Again, I'll label this in words as well here in just a second, just for visualization's sake. So, grab my handwriting brush back. We're going to leave that little, no, just kidding. I can't do it. I just can't do it. Sorry. This up here, all the yellow is the interior. So the same for over here. So this right here and this right here as well. And all of this on the outside is called the exterior of the angle. This pretty really makes sense. It's not really that, this part is not that complicated. We haven't gotten to anything particularly hard yet. Exterior, how do you spell that word? Just like I'm spelling it. I'm doing so good. Give myself a pat on the back. That's great. All of this on the outside is the exterior of these angles, right? Now remember that these rays, they would actually go on forever and ever. So inside and outside of the angle. So there's all of those things. Now, I already kind of let the cat out of the bag, but let's talk about 3 different types of angles. 3 different ways to classify an angle. There are 3 of these. There is an acute angle, which you probably have already seen. Acute angle. And the way, if you've never heard of this, the way to remember what an acute angle is it's acute little angle. And its measure is less than 90 degrees. Okay, so an example would be something like, let's draw all of these kind of from the same direction. That was actually really a straight line that I drew on accident freehand. Good job. So this angle in here is less than 90, right? And so the next classification is an obtuse angle. Obtuse angle. And that is where its measure is greater than 90 degrees. So something like this would be an obtuse angle, where this angle is bigger than 90 degrees. And then finally, of course, is our favorite, the right angle. It's our favorite because there's so much cool stuff you can do with it. Just wait till we learn about a little bit of trig stuff. So that one, its measure is equal to 90 degrees, right? So something like this. And it's really important. Now, this next sentence or phrase or paragraph is going to be really important. And that is, if, this is really important in geometry, we're going to learn about proofs and whatever else, and you're going to be tempted to try to prove something by saying, that's a 90-degree angle, when it's not actually labeled as a 90-degree angle. And so this is really important. If it doesn't say it's a 90-degree angle, it's not a 90-degree angle. Now, so the way we mark a 90-degree angle is with, I'm holding the wrong thing. No, I'm not. What is this doing? The symbol for a 90-degree angle is this symbol. We got to put a little box in the corner. That means it's a right angle. That means it's 90 degrees. If it doesn't say that, or we don't have some other information in the given or something saying this is a right angle or its measure equals 90, then it's not. So if it's really close to a 90-degree angle, but it's not labeled like that one, we don't know. In fact, this one is close enough. We don't know whether it's obtuse or acute. It looks to my eyes like it's probably acute, but I don't know. And if it's not labeled, we don't know. And that's really, really important. You notice I'm using my exaggerated voice. This is really important. If it doesn't say, we don't know that. So for a proof or something like that, you can't just say it's a 90-degree angle unless it's actually given that way and listed that way. So I said we're going to do one example. So let's do, there is actually one more piece of vocabulary I think that I forgot because it's hidden over here in my notes. Yes, it is. So that is the word bisector. So we have got 2 different types of shapes. The word bisector. I think this was maybe something that I forgot when we talked about line segments as well, but that's okay. We can pick this up and here. And that is something that cuts something in half. It bisects it. So if we have a segment, I'm going to go throw this in there because I know I didn't talk about it. It was probably supposed to be when we were talking about segments, but I'm going to throw it in here because I am. So there you go. So if we have a segment bisector, then that means that we have the segment cut in half. Whoa, that didn't really work very well. Let's try again. So that would mean that if this guy, and I'm just kind of talking in generics. We could label this and we could write it all out formal, but I think this is probably good enough to get you what you're doing. So if this segment bisects this other segment, then what that would mean, and this is important for when we do proofs and stuff, that would mean that this and that are equivalent. Now, I think we've talked about this in another video, but it all starts to run together. So if we haven't, we'll throw this in here too, that these tick marks mean that those two are congruent. If we had like 2 tick marks, that would also mean. So like if we wanted to say these two are congruent and then we add some points in here to make that a segment, we could also say maybe those were congruent. Just like with the 90-degree angles, just because it looks congruent doesn't mean it is. It has to say it, has to be labeled, has to be given that way. That's really important as we continue on later. So I'm getting loud about it now. So in this video, we're talking about angles. So where we're talking about now and what we're going to see in our example here in a minute is that you might have an angle bisector. So like if we have this guy right here, and these will be usually labeled, like we might have angle ray, say AB, let's pretend, bisects angle CB. Or whatever, right? That's how you might see it labeled. We're going to see that here in a minute on our example. And the way you would mark that, there are you see it 2 different ways in different textbooks. I usually just use the curved little arc thing. So like this is congruent to that. That's usually how I do it. Sometimes you will see this method combined with that method as well in different textbooks where they also add little tick marks to say that this is congruent to that and whatever else. I usually just do it with the arcs. And so if I have multiple ones, then just like I might have multiple tick marks, I would have multiple little arcs. Like, so these are congruent to that one, right? And so that's how I usually do it. So now that we've got all our vocabulary bits, let's do that example. So here is the example. In the figure, ray, KJ, so that is, let's stick another drawing layer on here so I have something to write with. Ray, KJ, and KM are opposite rays. Oh, look, there's another vocabulary bit that I forgot. I think I hit this with bisector on that other one. But opposite rays are rays that are collinear. I'm going to add this as a note up here. So they are linear, with shared endpoint. Endpoint. Okay. And they also go in opposite directions, right? So if like KM would be equivalent to K, let's see, how about X, right? Those are equivalent rays. But opposite rays are 2 that go in the opposite direction. So their direction is in the opposite, which makes sense, right? That a lot of these early vocabulary things are almost common sense. Like if you understand the word opposite, you could probably figure out what an opposite ray was, right? So anyway, back to the problem. So KJ and KM are opposite rays. So they share an endpoint. And KN bisects JKL. So when we hit something like this, it's really useful, and this is going to be, as we do these problems, if you, in our videos and definitely in my class, talked about the fact that geometry is full of puzzles. So the more we can start kind of notating the clues and the pieces of the puzzle, it's going to be helpful. So KN, the fact that KN bisects JKL, so that would be this angle. Let me change colors actually. Let's label. So this angle right here would be this one, right? So this angle, and KN bisects it. So what does that tell us? Well, that tells us that this angle is congruent to that angle. Obviously, I didn't draw it to scale, but you get the idea. And since this is kind of flowing over, I am going to go ahead and add the tick marks. I don't usually, but just to make it more clear visually what's going on, because it kind of looks like it's flowing all in together. And so for the sake of confusion. So if the measure of JKN, so let's label that, JKN equals 8x minus 13. So JKN, let's grab us a different color. So that's this one, J, K, N. So this one is 8x minus 13. So that's this one, which means that because they bisect, see, we're filling it, we're just putting pieces of the puzzle. I know I haven't even finished reading it, but a lot of times it's easy to just add as we go. So that means this is also 8x minus 13. This angle would be NKL or LKN, right? If that and NKL, oh, look at that. That's the same as that one. That should give us a clue that should give us a clue to what kind of formula we're going to write here in a minute. It's going to be a lot like ones we've done before. So the measure of NKL, let's go one more color. How about this purple color, right? NKL, so this guy right here, which is the one we were just talking about, also equals, we've almost just built a formula over here in the corner, right? Also equals 6x plus 11. You see, if we add the pieces as we go, the puzzle just kind of falls into place. Sometimes they're more challenging, but if we label well, it's great, which is why a lot of times, unfortunately because it takes more time, it's very often easier if you will copy the problems for like the book or whatever into your notes or into your homework. I know it takes more time and effort and all those things, but it can really be worth it because it can make it a lot easier to do what you're trying to do. So we're trying to find the measure of JKN. So I'm going to go ahead and label that as white. So JKN. So that's this guy right here. This one, this angle is the one we are looking for. What was that noise? Oh, it wasn't even me. It was my lovely wife who's down here working with me. Yay. Everybody say hi, Miss Rochelle. Okay. So we already have our equation that we can use, right? We already have a single equation with a single variable. Let's just rewrite it nice and neat over here. So 6x plus 11 equals 8x minus 13. This is probably an equation that you can probably do in your sleep at this point. It's easy peasy lemon squeezy. So let's solve it. So let's subtract 8x from both sides. And let's subtract 11 from both sides. At this point, we've done a lot. We've practiced a lot of these in Algebra 1. I think we can put both of these on the same line, especially since we're keeping it nice and neat and not get into too much trouble. So these cancel and those cancel. So over here, we have 6x minus 8x, which of course gives us negative 2x. We subtract and keep the sign of the bigger one, right? Equals negative 13 minus 11, same sign, add and keep the sign. So negative 24. All we got to get rid of is that negative 2. So we're going to divide by negative 2 on both sides because it's multiplied. That cancels, leaving us with x equals negative 24 divided by negative 2 is positive 12. Now, it'd be tempting to just circle that and move on with our life, right? But we're not. We got to go up and make sure we answered the question, which we, of course, didn't, right? We're not done yet because we want the measure of JKN, this angle right here. So what we have to do in order to figure that out is we have to take and we have to plug in this one over into this x right here. We could actually also plug it into that one because they're equivalent, right? So it would actually work out either way, but we're going to go ahead and keep it right there. So let's do 8, substitute in 12, so 8 times 12 minus 13. 8 times 12 is, of course, 96. And sorry, had to sanity check for a second. Excuse me. 96 minus 13. And then 96 minus 13, of course, is 83. Now, this is an angle measure. We can assume at this point, all right, that the answer is going to be in degrees. We haven't even learned about radians yet, so we can assume that. I know. I just made this big deal about you can't assume it unless you see it. But as far as angle measures, we can assume degrees for now. I don't know for sure if I would even. Well, actually, I don't know that we really can. I'm going to make a big deal, and we're going to keep it that way. They didn't give us units. We're not going to put units. There it is. So 83 is the answer to that one. That's our example. That's angle measures. We're done with that one. In the next video, we're going to talk about angle relationships. Mostly, it's going to be a bunch more vocabulary. I look forward to seeing and hearing from you there. If you're one of my students, do your homework. I'll see you in class. Thanks for being here. If you're not one of my students, thanks for joining us. Make sure to like, comment, and subscribe. We appreciate all of that. Let us know in the comments how we can help you with math, science, or your general homeschool journey as well. Thanks, and have a wonderful day. Bye-bye.